Hi, everyone. So before we start, I'd like to ask you a question. Please raise your hand if you know me personally. No one here. Please raise your hand if you ever listened to one of my talks or saw them on YouTube. No one. Which is pretty good, because I guess all of you didn't come here to listen to me talking, or because of me. You came here because you saw the title, Building Your Own Bot with GPT, and it really attracts you. And not only that, you also, hopefully, you also read the abstract about this talk, and it's a really good abstract about what we're going to do today. And I've done a few title and abstract, and I can say that this is probably one of my best. It's a really good title and abstract. And I can say that without being arrogant, because I didn't write it. It was all written by the chatbot GPT. I just need to give some description about what I want to talk about, and it gave me the full title and the full abstract. I only need to do small modifications. So I guess you all know what GPT is. It's 2023 now. We all know what it is. It's really good in giving you title and abstract if you ever have a talk and you need to give a talk. Also, I guess you also played with it a little, and you know it's really good in generating code, or using that or Copilot, or any AI that can generate code. It do a really good job on that. Also, some people now are being really creative and artistic, and also it's really good in writing your poems, and composing recipes from what you have in your refrigerator. It can also give you really creative receipts. And unfortunately, also giving some wrong facts sometimes, and making up answers when it doesn't know something. So ChatGPT can do that, and probably a lot more than that, as you noticed, but it has two pain points. One, it's a trained model, so it sometimes can be outdated data. It was in the beginning when it was going out, it was data until August 2020, and now they're making it better and better on more refreshed data. But something that you probably notice, a pain point, that it's only opened with public data, which is really good if you have something in the internet, giving some answer about the world or anything that Google can find. It can also give you some answers. But what about your data? What about your context, the data of your company, the data from your files? So it probably can't give you answers about that. So what if we can build our own personal bot that can answer any questions about our own data, about our own files? So this is what we're going to do today. So let's do a short demo. So what we want to build is this kind of smart folder that everything that you put in it, any data, any content, can be any type of files, from movies, from podcasts, from documents, anything that you put inside it. The bot can understand the content and answer your questions about it. In this example, I have this lease agreement that I got from my landlord yesterday. I want to put it inside this folder and answer questions about this lease agreement. So for example, if I just go to the document and search, can I bring a dog? The word dog doesn't appear at all, so I don't get the answer. But if I run my chatbot, then I'm asking the question, can the tenant bring a dog? It's smarter than that, and it can understand the context and answer me from the document. No. And if I ask him another question, for example, what are my responsibilities? As you can see, it gives me the full answer from the documents. It's not from the internet, it's from the document about my responsibilities as a tenant. And this is pretty long and really detailed, so yeah, explain me like I'm 5 years old. And it can give you a shorter answer, and maybe even shorter. Let's do it in three words now. And as you can see, maintain compliance and sure. This is what I wanted, right? I don't want to read all these lines. It's enough for me. Cool. So let's build this folder together now. Let's start. Well, nice demo, obviously. But let's see how we actually build it. So first, we need to understand what ChatGPT is, right? It's just a web server. It's a website. It's a web server to demonstrate the abilities of the GPT-4 model. So you have their page. You have their web server. You have a UI, which is the web page. And you have some features on top of that, like login, sessions, right? You need to log in. You have the session opened. You have some plans, like the free and the paid. You have the chat management, so you can go back to your chats. You also have some chat history, right? You can chat and then get an answer, ask another question, get an answer, ask another question. This is another feature. And it's based on some models in the back end, like GPT-4 or GPT 3.5 and Codex. So that's for the ChatGPT. What we're going to build today, our personal bot. We are not going to implement all the features. We're not going to build a website. While you can do that, obviously, it's not that hard, but it's out of context from this talk. Probably you know how to build a website if you're developers. So we're going to do the simplest thing, which is building a desktop app. For the UI, we're going to use CLI. We're not going to build login, sessions, plans, chat management. I guess you know how to build that. We are going to build a chat history, which is probably an integrated feature for every bot that we need to build. And we're going to use GPT 3.5 model. GPT-4 is also open now for waitlist and for paid users. So for now, we're going to use the free version, which is GPT 3.5. So when you think about building your own personal bot, you probably think about training a model, right? You heard about there's a model, and you can train it with your personal needs. So can we train the GPT model? Well, yes, we can. We actually can, and it's called fine-tuning. And it can work for some cases, but it also has some downside. Not sure that it's good for what we want to build. The first thing, the fine-tuning is built more for classification cases. You need to give it a set of prompt and completions. So in our case, we have a lot of documents and text. We don't have prompt and completions. So it's not really good for these kind of fine-tuning. Also, it requires, for the fine-tuning, you need big data sets. And we also don't have these. Sometimes we have just a PDF with two pages. Also, not sure it's good for if you have you want to build this for multiple users. Each user has their own data. You don't want to train thousands of models now and hold thousands of models, right? We need a much simpler solution than that, than fine-tuning a model for each user. So obviously there is an alternative. What we're going to build today, we can build what we want to build, personal bot with prompt engineering, completion API, and the embedding API for OpenAI. That's what we're going to do today. So first, probably the most basic API that OpenAI gives you, or any other natural language process model, is the completions. Completion, you can think about it if you have a question, you ask a question, and the model completes this question with an answer. You can also start a story, and the model will complete the story. So what's the API? It's chatCompletion.create. Then you give it an input. It has some multiple parameters, but the most important one is the messages, which is a list of the conversation. It's a list of objects. Each object has two fields. One is the role, can either be the user, the thing that the user said, the assistant, which is the answers that you got from the bot, and some system directions. For example, you can tell the bot to behave like something or give them some instructions how to behave. And the other field is the content for each message. And as an output, you get the completion, obviously. There are some fields there, but in the data, you can find the actual text for the completion for this conversation. So if we want to build our personal bot, this is, by the way, it's kind of like a Python. I know this is a Java conference, but I'm sure you can understand this. So query, just get the input from the user. Then with this input, get all the relevant, all the content that you need, all the content that you have in the folder. Then you have the messages. You put the message, the role is the user, and then answer the query with the context. Okay, then you can print the answer. So you get all the content that in this folder, and then you have this. You go to the bot and you ask a question. And that's all you need. Thank you very much. Not really, not really. It's not that simple, right? You probably noticed that we're taking the content for all the text, like all the string that we have in a folder, which can be really big, right? If you have like one PDF, it's easy, but what if you have like 1K files with hundreds of pages? First, it's really costly, right? You pay by token, and we're going to talk about tokens in a second. You can think about for now as a word, but you pay for every word that's in these pages. Also, there is a limitation. Completions has like a token limit for around like 4,000 tokens. It's around 3,000 words. And also, if you didn't have that, like this cost and limitation that came from OpenAI, you still have the latency problem, right? You can't like send like for every question sending all your data over the internet, gigabyte of data over the internet, over the network. So I thought we were going to talk about tokens. So what are tokens? So these models the terms is not words, it's about tokens. Token is a model semantic atoms. So if you want to do an example, there's a website here, you can just like put your like text and then it breaks it into the tokens. If it's very simple words, like tree, fire, water, each word will be one token. But if it's more complicated, like psychotherapist, it will be broken to a few tokens. Also, question mark is a token, exclamation mark, and so on. So as a rule of thumb, 100 tokens equals around 75 words. And if you want to know how much tokens there is in a text, you can use a token library. So now again, now we understand what the tokens are, so it's costly. Our solution will be very costly. It has a limitation of 4,096 tokens and latency. So we need to find a better solution, right? So what's a better solution? The solution itself looks pretty good. We need to change one thing in our code. Instead of getting all the user context as a text, getting everything that's inside this folder, we only need to get the relevant content for a given query. So how do we do that? This is the second API, which is embedding. So embedding created the API. You send the input, which is the text, any text that you want, and a result, you get the data, which now is not a completion, it's a list of floats. The list length is 1,536 of floats. Each float is a dimension, right? So we have a multiple dimension answer, a multiple dimension vector that shows us where exactly this text will be in the model. So let's do an embedding model. So I guess you can't imagine like multi-dimensional metrics. So what we're going to see in this demo, we're going to take a few words, a few texts, and we're going to take the metrics, we're going to send it to embedding, put all the vectors into one matrix, and then compress it to 2 dimensions so we can see it actually in something that is visible to humans. Right? So we're going to put all these texts. I put some text here, cat, dog, bird, then white, green, red, joy, depressed, fear, and I'm not going to send the category to the model, only the text. The category you're going to see them in the chart. And there's another word here, which is blue, which is obviously should be next to the color category. And as I say, I'm going to read the JSON. Then I'm going to get all the embeddings for all these words with the OpenAI API. Then I'm going to compress it with TSNE algorithm to 2 dimensions vector. And then I'm going to chart it. So let's see it now. We're running the code. And let's enlarge the dots so you can see now how it looks in a 2-dimensional matrix. So you can see here all the moods are quite near each other, same for animals, and same for colors. And for the color blue, as you can see, it's also pretty close to the other colors. Cool, so now let's do a really small change. And instead of blue, let's change one word, and let's do it, I'm blue. Now, obviously, I'm blue means something else. It means I'm depressed, I'm sad. And let's see again, let's try it again. And as you can see here, it moved actually to be one of the moods. So now the model interprets this word all differently. So it's much smarter than just like breaking the words and understand where they are. It's actually understand the context of the sentence. Cool. So as you can see, embedding is as its own, just like getting the vector with all the floats. Doesn't help you a lot, but you can use cosine similarity. Cosine similarity is just a mathematical formula to understand like how similar two vectors are. While it looks a little scary maybe, it's just like multiply each element in the vector, then sum it all up and normalize. So it's really simple calculation. Really easy for computers and not heavy CPU. So how are we going to build our solution? First thing, we're going to take the text, every text that is going to be inserted to our magic folder. We're going to extract the text, break it into chunks, and we're going to talk about this in a few slides. But we're going to break it into chunks. For each chunk, we're going to send it into the embedding API, and then we're getting this vector. I'm going to save it for now in a CSV. So we have for each text the embedding. Okay? So now after we build this kind of DB, whenever there's a query, so what we're going to do, we're getting the query embedding. We're going to send it to the embedding API. Then we're going to run cosine similarity with every entry in this CSV. And then we can sort by cosine similarity and get the top 3 results, or top 5 or top 10. This is up to you to decide. We're getting the top results. And from this, we have the text, the context for our question, right? The user asks us a question, and we have the concrete context in our files. So if we go back to our solution, again, so we have the query. Then instead of getting all the content, we're getting only the relevant content for the query. Then we're going to build the messages, which is the role user, and answer my query with the context, and print the answer. That's all you need to know to actually build your personal bot. This is all the algorithm you need to do. And you can now go and do that. But you probably don't want to build the same bot as mine, because this is already exists. You want to build your own personal bot, and you want to tailor it to your needs. So what you need to think about, first thing is extraction. Where do you extract your text from? So in my example, I extract my text from files. For text, just like text files, I just like open the file and take the text. For documents, I use PDF Miner and Python docx. Python docx for docs, PDF Miner for PDFs, obviously. For audio and movies, I used Whisper, which is also an OpenAI model that you can use. Also download it, not only for the API, you can actually download it in your computer. So I use this for audio and movies. And for public web pages, I use Python request. You can obviously use curl or something like that. But this is only for public sites. And obviously, you can do so much more than that. For movies, you can use OCR. For pictures, you can also use Clip. Clip is also another OpenAI model that describes a picture. This is another way to get some text from pictures. And cloud services, you can think about any like service that you use in the internet that is not public and get API for this. For example, if you want to build like a bot for your personal Google Calendar or any other service, just extract the text. Any service in your company, obviously. Anything that you can get text from. And I guess like more ideas, like any idea that you have to get text. Then after you get the text, there's another question of chunking, right? As we said, you don't want to send all the text if it's like a PDF with 200 pages. You have to somehow chunk it for the database for smaller like segments. So the question goes to how do you break this long text into chunks, and what size do you want the chunk to be? Because you pay, the longer the chunks will be, you pay for that. So as an example, I brought here the instruction. This is from my iRobot. As you can see here, there are the 3 paragraphs: charging, error, and system reset. It's really easy for us, like humans, to read that. But if I pull all this from the PDF miner, I pull all these text, I get something like this. And then I need to break it into the segments, right? So what I want to actually do is break it like you see it. Like there are 3 paragraphs here, but it's a little more challenging, right? There's no any really easy way to do that. So how do you chunk your text? The most naive way will be to just create every 50 words or 100 words, just create a chunk of text. Obviously, you probably notice the problem. It's not really break it the way you want. You can do some overlapping windows, for example, if you want to fix this. But it gives you some some beginning to start from. Something a little more sophisticated will be to make something format dependent, right? For example, in documents, you can do it by paragraph, empty spaces, anything that you want, or anything that there is a third library component. For movies, maybe look for visual changes, like in YouTube, or silent moments if it's a meeting. For web pages, maybe look for components, or look for the titles. This is something that you need to build it for your own case. I just built something generic, but if you want to build something for your own case, you should think about how you break it into the chunks. When I tried to do it with PDF Miner, it was something like this. It gave me even the title was paragraph, so it's not, as I say, it's not that easy as you think. So this is the second thing that you can do is by depends on your context. And another way you can break it into chunks is by semantic similarity. So this is a really naive algorithm. Break all your text into sentences, then get the embedding for each sentence, then do Cosine Similarity between each sentence and the following one, and then look for the local minimums, because the local minimum is where the context changes. And there are obviously more, this is really naive, there are more sophisticated algorithms to do that. So after we talked about extracting the text, breaking it into the chunks, also you probably want to enrich it with more context, right? If I have this is my CV, and you see there are a few chunks here, I broke it into the chunks. But if, for example, I worked in the blue here, you see I worked in Synapse Tech, for example. If I ask who worked in Synapse Tech, it doesn't know anything about the document, right? Because it's just a chunk of text. And if you have a book with 200 pages, if you just take a chunk of text from the page 197, it doesn't know anything about the book, the chapter, the owner, whatever. So you also need to enrich it. Depends again on your use case. If you're doing something more specific than just general solution, you need to think about how you design your solution so it also has some context about where it's from. Right? So if it's a book, it's the page number, the author, the title of the book, the chapter, or so on. If it's a meeting, for example, when did this meeting happen, where, who were the participants, and so on. Cool. So far, we talked about the algorithm. Now let's talk about the special spices. So anybody here likes to cook? Cool. So if you read a receipt is like an algorithm, right? It's just you read, there's instructions how to do every step, what you need to add. But then there's this line that tells you now add these special spices, your spices from your own taste, or the herbs. And this is something something that can differentiate between a good cook and a bad cook, right? And what's the special spices for this chatbot GPT? It's the way you construct your prompt, or the way you give the system the directions how to work with questions. And I can tell you that every word actually counts in the way you build prompts. And if you worked with ChatGPT, you probably know that, right? Sometimes you add a few words, and it gives you a whole different solution. So just our research that done by Takeshi Kojima in 2022, it wasn't done on the GPT model, but other model. So this guy gave the model, language model, arithmetic problems with 0 shot, which means that he just gave them the question, arithmetic problems, like two trains go from one city to another, when will they meet? Or a guy get 3 apples, then he gave 2, and so on. These kind of questions. So when he just gave this question to the model can be like 70, the success rate was 70.7%. So the model wasn't really successful in answering arithmetic problems. So this is for zero shot. When he tried to add some words, for example, the answer is after the proof, he could triple the success rate to 45.7. But when he said to the model, let's think step by step, the actual success rate jumped to 78.7, just by adding 5 words to the model. So words actually count. Like the way you design your solution, think about the words, maybe even think about if you have like children, maybe how would you say that to children? And this actually, like this sentence, let's think step by step, it doesn't work for all the problems in the world. It only works for arithmetic problems. Each problem has its own like design prompt and the prompt that is ideal for the question. So let's do another example. This is from the OpenAI documents. They tried to build like a support agent, and they told the bot, hey, behave like a support agent now, and they gave him a use case, right? The customer asked, I need beep internet. The technician is 2 hours away, and so on. And the answer the bot gave him is, my manager let me go at my regular time because there are too many beep like you that are demanding the beep internets. Now beep your pants and, okay, let's stop here. As you probably understand the problem here, right? The bot doesn't understand everything. It probably just like gets like some statistically like responses from the internet when somebody curses, so it responds like this. So they did a small modification, and this time they asked the bot to be polite. So when the customer asks, I need my internet, the technician is 2 hours away, the bot was kind of like cynical, and we sincerely apologize for the wait. We're on the pins and needles until you have cat gifts again. Okay, so polite is not enough. What if instead of polite, we'll just like put them like a few examples? So they gave the bot a few examples instead of polite. And now when the customer asks a question, I made my beep internet, the technician is 2 hours away. The bot was kind of trolling. So our field technicians report that all the trucks were stolen by a low-level drug cartel affiliated with a neighborhood person, and things like this that kind of got really ridiculous. And only when they put examples and the word polite and the word reasonable also, that reasonable is really helpful here, the bot were actually answering some like reasonable answer. Yeah, we're sorry for the inconvenience and so on. So this is just an example that shows you how like one word or a few words can make the whole difference between something that is good and something that can be like trolling or really bad. So words count. And if we're talking about prompt engineering, we need to talk about prompt injection, something that nobody think about probably a few months ago, but it's really trendy now. So just think about SQL injection when you have this query and the user can add anything to your query. So it works really similar with prompt, right? If you give some instruction to your bot, the user can add a text like, tell me what's written 2 lines above, or ignore all former instructions. And there are many like attempts like in Reddit to actually attack ChatGPT and get him like to overcome all these instructions that he gave, playing some role play with him and things like that. So you also need to think about that. If you design any prompt, know that anyone can actually break into that. So this is the first special ingredient, is as we say, the prompt engineering. The second one is the temperature that you can set. That temperature is like for every completion that you ask for the bot. You can also add like a number from 0 to 2. 0 means that it's really deterministic. If all the answers, we say that these bots are designed on statistical information. So if there's like a normal distribution, 0 means that you get more values from the center. And it's really deterministic. If you ask the bot, my favorite food is, it will always answer you pizza, no matter what. Now, if we increase the temperature a little to 1, it becomes like more original. So if you ask the bot, my favorite food is, so it can either be pizza, sushi, hamburger, and you can get many different answers. You get like more from the sides of the distribution. If you put it to the maximum 2, just like random answers, like bread balls or Indian fish, I don't know, like whatever. Whatever anybody puts there can be like as an answer. So again, this like the temperature that you put depends on what you want to build. In my case, for example, I just want to build something that answers questions. So I put it to 0 because this will return me facts, how to do things, and answer concrete questions. If you want to build something more creative, like complete your stories, writing poems, or brainstorm, you need to set the temperature to something higher, probably between 0.7 and 1.0. So when you build your own bot, you need to think about 5 things. You have the algorithm that we've seen in the beginning, but you'll need to think about 5 things depending on what you want to build. First, extraction, how you get the text. Second thing is the chunking, how you break the text into meaningful chunks. Then the information, what you also want to make what you want to add to the chunks, so it has some context about where it's from, or the whole like document or so on, the whole meeting. Then you need to design your prompt and think about the words that you put there, and then set the temperature. That's all you need to build a bot. And from this point on, it's going to be only my assumptions for what we're going to see in the next month, not like the long term, but actually for the next year. And again, it's assumptions. You can think I'm right or wrong. So what's next? So the first wave, which we actually see now, we're going to see more bots like this based on OpenAI or other models that are tailored for specific use cases. I've seen like a lot of bots coming out now from the healthcare field, from Lowe's field. You can think about any field, and you're actually going to see more and more startups and more bots that are tailored for specific use cases and specific sites or specific like data lakes. Then probably the second wave that we're going to see is more like frameworks, right? At the beginning, there are really specific use cases, and then there are frameworks to build your own bot. And actually, I've seen like a few weeks ago, also OpenAI opened the option to write a plugin to the chatbot. So you can actually only need to implement some APIs, and then you can be a plugin in the chatbot, so it's not only public data, you can also integrate with it. So this is the second wave. We're going to see more frameworks and startups. And then, I guess, like once there are more standards and more frameworks, we as content creators, as a website writers, we're probably also gonna need our content to be written for bots, right? Designed for bots, not only for humans. Now we're building our websites for humans, so everything is visual. There are many buttons to click, so humans can actually operate it. But in the third wave, when this becomes like the standard, we'll need to rewrite our content to be more designed for bots. And when I'm talking about design for bots, it's not the first time you've seen it, right? If you know about the semantic web stack, I have a link here, but I'm not sure everybody's familiar with that. But if you're not, you're probably familiar with the SEO, right? The Google bots. So you do have, like, in your site, you probably have some SEO that you wrote, like directions for bots. And accessibility is the same, right? You assume that not everything is visual, so you write direction to bots, to the screen readers, for people who can't see. So it's not the first time you're writing directions for bots. And this is probably where we're going to move. Like, it's going to be a huge movement from what we are today, which is Web 2, to Web3, and don't confuse this with a Web3 from crypto. This is a real Web3, not that bullshit, sorry. This will be the big change, really, because like the whole way we're going to write our content will change, right? The Web3, the semantic web is a concept that started a long time ago, and this is probably the point where it's going to move ahead. So we're going to move to more semantic web and more sites that are more based on natural language processing. Cool, I hope you enjoyed today. So what's next? You can see the algorithm in my program in my GitHub. Just for an example, you can take anywhere from there. It's MIT, so you can take anywhere and build your own bot. Really, go. It's really simple. Just take it and build everything that you want. Either it's API that you find in the internet, anything in your company, anything that you want. And then probably for a longer term question, think about how you're going to design your product now that we have bots and now that we have natural language. Probably in a few areas, this is what all of us were going to do. Not only website and HTML, we're going to think about a different way to build websites. So thank you very much. And I really welcome any feedback that you have. I think there are also, like, you can give a feedback in the website for this conference, but also you can ask me any question that you want, give me feedback. Really, I really welcome any kind of like questions and communication. I also stay around if you have any question, and that's all. So let's see if there are questions. So what's the difference between clustering? Oh, it's jumping. How to do? You can't see the questions. Okay, sorry. So I'll read it. What's the difference between clustering and the example with blue color you provided? I'm not sure I understood the question, but if there's someone from here, come to me after this. I'm not sure I understood the question. How to do this in Java, not Python? Actually, the OpenAI is just an AI, so you can also use curl, or I think there's an SDK to Java. So it's probably the same. You can think about this as also as a pseudocode. I don't think there's a huge difference. Again, if there's something I didn't understand, come to me after the talk. So you said about pricing. What was the cost of creating your bot? So it's free for the first $18. So for me, just like creating, this is why I encourage you to do that with GPT 3.5. It's free. You can just like log in. You have the first $18 are for free. After that, you need to pay, obviously. But GPT, they just opened GPT for a few weeks ago, which should be like 10 times cheaper than the GPT 3.5. I think I answered all the questions. Cool. So thank you very much for being here. And again, if you have any questions about scaling, about anything like that, I'm here to answer any question you have. Thank you very much.